Hello there and greetings to everyone. In this video, I will be presenting the project titled IoT based online temperature monitoring system and predictive analysis of faults for electrical equipments, which I have completed and submitted as an entry to the BoltIoT Innovation Challenge. As we are creating a system that monitors both temperature and fault, we need to know their relation. Impermissible temperature rise in many machines and motors can be the result of overload, coolant failure, or insulation breakdown, each of which give rise to high amount of current in some parts of the system, thus giving rise to immense amount of heat and thus increasing the temperature of the system. Thus, if we monitor the temperature precisely, we can get a fair idea of when the system is under fault. We are now aware of the relationship between fault and the consequent temperature rise. Thus, monitoring temperature rise, we can get a fair idea of fault. This is exactly what this system does. This system monitors unusual rise in temperature and sends alerts via email and via Android app notifications. In order to simulate a real-life scenario, it also has designed a LED glowing and buzzer which is imagined to be on site where the fault has occurred. If there is unusual temperature rise, both the LED and buzzer will glow incessantly, in addition to email and Android app alerts sent to the concerned users. In this project, I have also designed predicting of temperature from current temperature data using polynomial regression that helps us to identify and know about possible temperature rise and accordingly take maintenance action, that is predictive maintenance. Before I go into further details, I would like to thank BoltIoT for giving this opportunity to participate in the innovation challenge. I am Tunir. Let's get started. First of all, I'll be going through the circuit connections. We have the LM35 sensor, a diode and a buzzer to connect to the Bolt Wi-Fi module. First of all, the LM35 sensor. The VCC pin is connected to the 5 volt pin of the BoltIoT module, the ground pin to ground, and the output pin is connected to A0 to read the analog value or the temperature as measured by the temperature sensor. The buzzer and the LED, as seen, are both connected between the 0 pin and the ground pin of the BoltIoT module. The additional feature that the LED uses is a 330 ohm resistor that is connected in series with it. Configuring the product, we first configure the Bolt hardware, where we select the A0 pin and name the variable to be temp. Then we move on to the code tab, where we write a code in JavaScript to plot data and also plot the prediction graph using Google Charts. Now, after the code has been written, we save the configuration and then deploy the configuration and finally view the device. Moving on to viewing the device. Actually, I had deployed the configuration a while back to get a substantial amount of data. Now, all I would do is to click on the predict button and 2 more graphs would appear. The red one shows the predict history and the yellow one shows the predicted points, that is the predicted data. For configuring an alert, we first go to the alert section of a Bolt cloud. Once there, we add on new alert. Since I already have created an alert, I would click on that. Now for configuring the alert, all we have to do is to add an alert name, condition and an alert message. Here I have added the alert name as high temperature, where I have put condition on the data of A0, that is A0 if greater than 200 sends a push notification to my Android app saying alert unusually high temperature obtained, check for fault. To get alert on the Android app, all we have to do is to push data to the cloud and set the threshold accordingly. I have set the threshold in such a way that we get alert in room temperature itself. Seems that we have our alert. Here it is. Now for the alert via email and the on-site alert using the buzzer and the LED in case of threshold breach for possible fault, we need some sort of Python code. So here I have my Python code. I have written and stored my API keys and my mailgun and my Bolt device IDs in a separate file and access them from here, since they are sensitive information and should not be shared with anyone. Now I have set the maximum temperature value or the threshold to be 200, which is around 19.5 degrees Celsius. I have intentionally done so in order to obtain a simulation of the system operation in room temperature conditions. Now all we need to do is to power on the device and run the Python code. Here we have our device. We have already powered it up. The green and blue LEDs are quite glowing properly, so we have both the Wi-Fi and the cloud. Now we would be running our Python code. So here we have the temperature sensor value of 208. There has been threshold breach, so mailgun has been requested to send the mail, and we find here that both LED is glowing and the buzzer is also on, giving quite a good sound. Now I'd be checking if there is email notification. Go to my Gmail account. Yes, I have it. Here I have the alert that says the current temperature sensor value is 208. So we have been successful in sending an email notification, as well as we have put on the LED and the buzzer based on a condition of a threshold breach. This is very important and crucial in case of a power plant or an electrical equipment to send out such an alarming signal in such a distinct way with a red light and a prominent sound of a buzzer. That's why I have intentionally not put it off. It has been assumed during the course of this project that in real-time application, the buzzer and the LED would be put off manually from on-site maintenance personnel who have attended to the fault of the electrical equipment. So this is my project, which I have submitted as an entry to the BoltIoT Innovation Challenge. Thank you for your time.